Rock exhibit a brittle type behavior, unconfined, but become them more plastic. as the level of confinement of increases. Condition in the field are primarily compressed and vary from unconfined near the opening walls to confined at some distance from the opening. The strength of rock is affected not only by fact, factors that related to its physical and chemical composition, such as its mineralogy. The porosity, cementation, a degree of alteration, or weather or water content, but also by method of testing, including such factors as sample size, geometry test procedure, and loading rate. Uh, the physical properties of rock affected design and construction of rocks are mineralogical composition, structure, and texture, uh, specific gravity, unit weight, density, wide ratio, porosity, moisture content, degree of saturations, coefficient of permeability, electrical and thermal property, and swellings. So these are the generalized properties of the concept of the phenomena. So coming to the one by one texture, uh, metallizing compositions, texture. Texture is defined as the interrelationship of different mineral constitutions. In the first point is texture is defined as a interrelationship of a different minerals constitutions of the rock based on the linkage between the individual grades of the rocks are broadly classified as a variable each interconnections of the grades, coherent water coalescence bonds between the particles. Hard rocks, rigid elastic bonds. The bonds in the hard rock in the strongest and also as they are mostly come across in mining operations. A further insight into the size and shape of the mineral grains, which will determine the area of contact and the nature of the bond between them, are important factors. Based on the texture, the rocks are divided into statistical uniform distribution of the minerals of the approximately equals to granular and matrix type. From equigranular or further classified based on size of the mineral grains and size of the rocks. The matrix type are further classified into isotropic, equidimensional grains, and spherical pores or anisotropic, elongated grains, including porous. The anisotropic are again classified based on the orientation of the elongated features as a linear one. These indices are attempted to be expressed in the quantitative. Further, rock properties are affected significantly by the dominated minerals and together sharply different in properties from the dominant based on the ratio of these two. The coefficient of in human genetics is evaluated from which reason factor can be determined. The texture and the structure of the rock is governed by the genesis of origin of the rock. In the case of sedimentary rock, the conditions of sedimentary consequently changes of porosities and properties. And second point is here, specific gravity is one of the important property of the rock. Unlike metal elements, component, and even mineral, the specific gravity of the rock is always influenced uh, by the sum total of all void in the mineral particles or aggregates in the rock. The specific gravity of the limestone varies from the 1.5 to 3, while the specific gravity of the construction metal calcite is 2.7. They show the density of expressed in different way in grain density. True specific gravity, only the solid grains are taken into account. Apparent specific gravity or unit weight, where the grains and the dry wide are also taken into account. Bulk density, where the grains voids and are liquid filling the voids is also considered. The last value naturally needed specifications of temperature. The specific gravity of the most common rock forming minerals ranging between 2.6 to around 3.2, where the rock is table. Some of relations specific gravity further we will look at this. Then the third one is unit weight. Porosity is there. This is also a very important factor. Porosity is expressed in percentage of void is the total volume of the rock void ratios. The ratio of the volume of voids, volume of solids is another way of expressing the porosity volume. Apparent porosity determines the quantity of flow of water as it takes into the consideration of only the void space, but that are interconnected and hence is of lesser volume, the actual porosity. Porosity has a great influence on the rock property. Increasing the porosity reduces the relative area of the contact between the rains for the transmission of energy, shapes, size, and mutual connections of the void present in the rock determine the form of porous space in the rock. The size of porous are classified into subclassifications. Other properties are so degree of saturation, coefficient of permeability, electrical and thermal properties, swellings. These are the also very important for the knowing the physical properties of rocks concerned. Here is also same ductility. Some other properties also given here. And let us minimize this one. Right. So this is one. Another go for similar one. Right. Physical property of rock material. Meteorological compositions is a intrinsic property controlling the strength of the rock. Although there exist in more than 2000 kind of known minerals, only about 9 of them are take diversified in the forming of composition of rocks. They are quartz, feldspar, mica, uh, hornblende, pyroxene, Olivian, calcite, kaolin, and dolomite. Speech specific gravity in the ratio of the density of the solids to the density of the water. This is a ratio between the where the mx is the maximum solids. Vx, a volume of solids. So unit weight can be W by V is the total weight of the sample and V is the total volume of the sample. Density is a measures a mass per unit volume of density of the rock. Material varies and often related to the porosity of the rock. It is a sometime defined by unit weight and specific gravity. Most of rock have density between the 2500 2000 kg for the dry density, bulk density, and all the structural density. So physical property of a rock material, the void ratio is the ratio of the volume of voids. It can be VV to the volume of solids, Vs by Va. A simple calculation by unit weight of the water can be calculated. The porosity, therefore, the porosity of part. Physical properties also have unit when porosity. So another physical property is moisture content. It is the ratio of the weight of the water in the void to the weight of the dry solids in the rock samples. It can be expressed in the ratio by WW and WA, where M is the moisture content, WW is the weight of the water, and WS is the weight of the solid. So this is a simplified formula for the calculation of the moisture content is concerned. Degree of saturation, yes. It is defined as a volume of water in void to the total volume of the void in the rock samples. So S equal to saturated W by VV, where VW volume of water and VV volume of voids. The rock mass having higher porosity has a higher degree of saturation, permeability, the ability of the porous material to allow a liquid to pass through the porous unit, um, um, cent per second or a meter seconds. Q is equal to K discharging through the area, hydraulic gradient. Electrical properties. Most of the rock are electric natures and moisture measures of dielectric content used in for data interpretation. Electric resistivity method used in the geophysics perspective. Thermal properties increases in the temperature makes a rock weaker due to the formation of the cracks in the rock mass. Coefficient of the thermal expansion of the rocks increasing the length due to the changes in temperature. The swelling, it is an increasing the volume of the mass due to the suction of water or due to contact of water for the long term. Swelling is more in weaker type of rocks. Anisotropy, properties of the elements of the rock mass are not similar in every direction due to the sequence of the rock formation, due to the existence of the bedding planes, etc. This is one of the property of the rock properties concept. Anisotropic material has some weakness in the particularly direction. Sensitivity of a rock have high degree of anisotropy. Durability is the resistance of the destructions. If rock is more durable, means it will last for the longer period when it is to use. It depending upon the nature of the environmental against which the rock is going to be used. Swelling index of RST stake durability test is used to the describe the nature of for the weathering. In considering the behavior of the rock as an engineering material, it transitions from intact rock to heavily joined rock mass. The quantity and quality of experimental data decreases rapidly as one move from the intact rock samples to the rock mass. Because the small samples are easy to collect and to take under a variety of laboratory conditions, experimental difficulties of increasing significantly in a testing in samples with a single set of joint to multiple sets. Further, the full scale of testing on joint rock mass is a really challenge, both in terms of testing as well as the expensive. Taking all these factors into consideration, it is a seem that the underground excavation design should satisfy the following requirement. It should adequately deserve the response of a response of the intact rock sample of the full range of stress conditions likely to be encountered underground. These conditions ranging from the uniaxial compressions tensions to triaxial compression. It should be capable of predicting the influence of one or more set of discontinuous upon the behavior of the rock sample. It should provide some form of the projections, even if appropriate. The behavior of the full scale rock mass containing the several set of the discontinuities. So another properties, mechanical concern, um, the strength ability of the material um, to resist an extremely applied load, but in rock mechanics, strength of the forces per unit area required to bring about nature of the rock mass. It give the environmental conditions also. Classification of the strength of depending on the type of loading and its stresses. The strength is generally may be classified as compressive strength, tensile strength, shear strength. For determining the above strength value, the testers are conducted either the intact rock specimens in the laboratory test or rock mass in the field in situ strength test. In the laboratory, there are direct methods for the determining above strength. Volume of the laboratory are also indirectly methods for the determining above strength volume rough, roughly in the laboratory or at the field site. The comparison strength of the material is a measure of its ability to resist the uniaxial compression loads without yielding or fracture. The most common measures of the compressive strength is a uniaxial compressive strength or uniconformed compressive strength. It is one of the most important property used in the design, analysis, and modeling. Direct method, uniaxial compressive test, triaxial compressive test, and point load test. These are the other mechanical. By applying the external force, how the behavior of the rock is studying is also a mechanical thing. The physical is already the natural the formation, the structure and porosity, moisture content. These are the physically color, luster. These are the physical. But mechanically, when you apply the external load on this, so how it will be behaving? What are the breaking strength? What are the compressive strength? What is the tensile strength? These strengths can be understood. So uniaxial compressive strength UTM rock material and deformation behavior under loading is varied by applying compressive load until failure occur in the core by the fracture made middle using high capacity compressive testing missions. ISRM standard for testing rock specimen in laboratories. The test specimen shall be right circular cylindrical having the height of the head diameter ratio 2 is to 1 to 3 and diameter preferably is not less than the NX core size approximately 54 mm. The diameter of the specimen should be referred to the size of the largest grain in the rock by the ratio of the at least to 10 is to 1. The end of the specimen shall be that 0.02 mm and shall not be depart from the perpendicularly to the other specimen by more than 0.00 radians at 3 mm or 0.05 mm in 50 mm. The side of the specimen shall be smooth, free, and abrupt irregularities and straight to the within the 0.3 mm or the full length of the specimen. The use of capping material or end of the surface treatment other than the matching is not permitted. The diameter of the test, the diameter of the test, the diameter of the test specimen shall shall right, right. About the upper height, the middle height, lower height of the specimen, the average diameter shall be used for the circulating from the cross sectional area. The height of the specimen shall be determined to the nearest 1.0 mm. Yeah, other ISRM standard for the uh, testing of rock specimen laboratories. Samples shall be stored in no longer than the 30 days. This is one important to accept. In such a way as a preserve the natural content. Preserve no longer than 30 days in such way as a preserve the natural content as far as possible and test in that condition. This moisture content should be reported in accordance with the suggestions methods for determination of the water content of the rock samples. Load on specific specimen shall be applied continuously at the constant stress rate, such as the failure failures occur when the 5 to 10 minutes, and loading alternative to the stress rate shall be within the limit 0.5 to 1 megapascals. The minimum load on the specimen shall be recorded in newtons or uh, whereas approximately within the 1%. The number of specimen tested should be determined from the practical considerations. The at least the five are preferred. Uniaxial compressive strength UCS is given by the ratio of the load at a feature of the rupture of the cross sectional area of the specimen. If the ratio of the rock specimen in the large plan, the measurements compressive strength, this is an equation of the diameter of the specimens is concerned for a mechanical point of view. This is a compressive stressed mission. You can observe the sample collection and load on that particularly. Yes. This is a UTM mission under testing. So compressive stress mission, point failure behavior. Compressive strength, the load, how the behavior of the compressive testing. Some tests are conducted here. This is a impact point load testing. Right. So the specimens, rock specimens before and after the failure of the Tensile comparison. A point load test rock can be conducted in the diametrically and axial diametrically, and axial in a diametrically test for rock core specimen for diameter D is loaded between the point load apparatus across its diameter. The length diameter ratio for the diametrically test should be greater than 1.0. Uh, Uncorrect point load strength, that is calculated IS equal to P by PD square, where the load of failure in kilonewtons, equivalent diameter for the circular core. The point load test is conducted in the field on a unprepared rock specimen using a simple portable equipment. It involves compressing mainly rock piece between the 2 points. The point load test is calculated as the ratio of the upright load to the square of the distance between the loading point. The point load test has a number of variations such as diametrical test, axial test, and irregular lamp test. The variation should not be confused with the Brazilian test. This strength is correlated with the tensile strength as well as with the compression strength. Because of the predominance of the compressive stress in rock mechanics problems, it is observed that for finitude constraint results. So L greater than 0.17 diametrically compression. dy L equal to 1 is to 1 in the axial test, and dy L is equal to 1 to 1.5 in the regular line test. So density is a term how heavy an object for its size. Density is usually expressed in units like grams per cubic centimeters, kilograms per cubic meters, pounds per cubic inches. So rock consideration a high density. So the density of the rock is often good identification tool and useful for the distinguishing limestone quartz 2 grams per centimeter. This is a limestone density you can be measured with this much of it for this much of volume. And granite almost 2.7 to 2.8 are all common low density rocks. The basalt, one of the most common kind of the volcanic rocks, can be has high density 3 different crops. And others. And same specific gravity already we learned, but once again we repeat here. Specific gravity is the ratio of the mass weight of a rock to the mass of the same volume of water. Water has a density of 1.0 gram per centimeter square. So that numerical volume or specific gravity for the rock is the same as that density of the, because specific gravity is a ratio. It has no unit. Specific gravity is easier to measure than density. The strength of the material defined as a load under which the material cracks and is disintegrated. The experimental definition of strength is determined by the increasing a load observed at the point at which the first crack appeared. It is obvious that such a criteria cannot apply to the piece of rocks which is completely surrounded by the other rock at the depth of the earth crust. The strain is a deformation caused by the stress. Strain may be dilation, which is change in the volume, or distortion, which is changes in the form of both. The application of stress to the material causing it deform. The amount of deformation is called strain. Axial strain, deformation along the direction loading. Lateral strain, the lateral extractions perpendicular to the direction of the loading. Poisson ratio, lateral strain by axial strain. So brittle material changes in the little and break suddenly. So this is a regular property of the rock, simplized some faulting and reverse faulting and strike to be shown here figures. For understanding purpose, brittle strain. This is called brittle strain is concerned.
Then this is also one graphical method representation. Right. Compressive strength with cylindrical specimens, the L equal to D is a D by L ratio. Uh, UCS 14 into is Indian coal measure rocks, 21 is in other cases. Uniaxial compressive strength and a point load strength. These are the samples collections. Right. This is a tensile strength test by nothing but a Brazilian. Tensile strength of the material is defined as a maximum uh, tensile stress, which is material is capable of developing. In nature, rock mass is rarely subjected to the direct tension, but it is subjected to the tensile stress. Rocks are weak in tension. Direct test in the in the rock specimen is subjected to the uniaxial tensile loading along its axis. The principal difficulties associated with the tensile test on the rock, the prevention of failure within the grips and the elimination of the behind in the specimen, the indirect method. This is a 2p by d, where t is the tensile strength, p is the maximum comparison load recording during the test. D is the diameter and D is the thickness of the test specimens. Stress is a force per unit area acting on a plane at any point within the material. There are three type of stresses. Comparative stress, equal forces that act towards the point from the opposite direction. Tensile stress, equal forces that pull away from each other. Shear stress, equal forces that operate in opposite direction across the body. Com- Compression stress and tensile stress, shear stress, folding and stretching and thinning is shearing, folding and folding. Porosity is an index of the amount of the groundwater that can be stored in the saturated formation. Porosity is the ratio between the total void or pores of the particular rock to the total volume of the same rocks. It is usually expressed in a percentage of the bulk volume of the rock. There are two type of porosity: primary porosity and a secondary porosity system is there. Primary openings, and these are the variety type of porosity, primary secondary openings of the rock samples. And then this is another is the capacity of the porous media to transmit water or liquid, relative easy flow of liquid under the unequal pressures. In fact, how rock will be act as a source of water for the well, the rock permeable when the rock has got many connected pore spaces, that is large pores and small pores, just like mechanisms are referred to the response of material to applied load, specific gravity ratio between the mass and the equal volume of water. Porosity measures the relative amount of the void space. Permeability measures the rate at which fluid will flow through the started certain material. Stress is force for unit area acting on the plan at any point within the material. The application of stress the material causes is to deform. The amount of deformation is called strain. According to above mentioned, features of density, specific gravity, strength, strain, stress, porosity, and permeability are the mechanical character of the rock. Porosity is a measure of the volume of void in a material or mass in a material or porosity depending upon the space between the grain in masses. It should be also include any space provided by the open fissures and joints. Intergranular porosity is often determined in the laboratory by comparison between the dry and sorted weight of the sample. To become fully saturated, void must be a contact, and both interconnections and void must be large enough to allow the flow of water under reasonable pressures. Next, one or both of these conditions is often not satisfied, particularly for the fine grain material, and the results of such sets are properly described as a apparent porosity. There are some porous rock, such as a vensular basalts that are porous, but whose porosity cannot be measured by the conventional means because of the void or not in contact, that is, the material is impermeable. Generally, three kinds of stresses are considered in the studying the resistivity of the rock. Comparisons of stress, which we try to describe as the volume of the material. Shear stresses, which tends to move one part of the specified with respect to other to make it flow. The tensile stress, which tends to produce the cracks and fissures in the material. Stresses are measures in pounds per square foot of the pound per the square inch. A compares the strength of the material such a rock as a stress required to break a load sample at that confined sites. So this is a simple example of calculation of the force by area. This is another compared strength of the rock. Some there in PSI units, not to represent unit using. The tensile strength of the granite also is given. And point load test. For the point load test, a comparison load is applied through two conical plates, which is cause of the rock to break in intensity between these 2 points. If the break load is P, the point load index IS can be then be determined. That is IS equal P by D square, where D is the diameter of the spacepan if the load is applied in diameter direction. The core D, where is the minimum cross sectional area of the spacepan for the plane through the plate into contact points. This is another procedure of the various typical mode failure value in the valid tests in the different areas. These are the under the UTM mission load sets, pressure scales. So how the behaviors can be studied for this purpose. Right. This rock mass classification is also another important, which is a historical rock mass classification has been based upon center recovery, which is real. Core recovery depends on many factors, including equipment used, uh, partial operationally techniques, and rock quality, and provides us no direct information on the hardness, weathering, and defects. Even good core recovery cannot be provided information equivalent to the obtained by field examination of a large exposure, although ideal situation is combined core recovery with the exposure examinations. So with this, I'm going to conclude and repeat once again uh, the various properties your studies from here. Uh, for uh, for studying of rock mechanics, we need these things in very essential properties for the knowing that particularly uh, there's some technical parameters also there. Unit weight is one of them. Movement and deformation under load, static and dynamic strength, indentation hardness, cohesion, angle of internal friction, Young's modulus, Poisson ratio, nature of the primary rock stress, impact resistance, resistance of the mechanical aberrations, crustability and breakability, breability, blastability, unity amount of drilling, unit force of cutting, coefficient and brittleness, coefficient of the plasticity, creep, delay density, density against water, scraptions, permeability to the water, wettability or wetting capacity, swelling index, softening index, strengthening ratio before and after, resistance to the weathering, resistance to the fast action, freezing and throwing, resistance to the chemical influencing, thermal properties, electrical properties. These are the all are the technical properties of the rock is concerned. Um, Particularly in the case of physical properties, mineral composition, structure, texture, specific gravity, unit weight, porosity, wide ratios, natural moisture content, structural moisture content, degree of saturation, permeability, chemical effects, thermal property, electrical properties. And all, as similarly, mechanical, you applying by external loads, you can be determine the rock compressive strength and tensile strength and Young's modulus and Poisson ratio, bulk modulus, rigidity modulus, bending strength, shear strength, punch test, torsion strength. So these are the all are the these are the complete rock nature when though that will give us to uh, method of cutting, um, uh, and also the method of approaching to the rock, and also how the rock can be stabilized in the when open cast bench, and high walls stabilization, raw underground cutting, everything is depending these particular properties. So the properties of physical and mechanical properties are very important study of the behavioral studying of the rock is concerned. I hope you today you enjoy this class. I wish you all the best. This with this concluding this class. Thank you.